In this video, we're going to learn how to add and subtract matrices. So before we go on, let us see what is the forms of these matrices. The first matrix is A. Now what is the form of the matrix A? We have 2, 1, 4, there is 1, 0, 3. So what will be the form of this matrix? Now first of all, we have 3 elements in the column running upward. Then if you run in the first row, which is going to be 2 and 1, you have actually just 2 elements there. So the name of a matrix will be written in this form. This is going to be 3 elements which are in the column, so this will be 3 by 2. Now 2 as a result of 2 elements which are in the row. So basically you want to write the number of elements which are in the column and the number of elements which are in the row. This is the basic way to write the names or forms of matrices. So by that, you should be able to write all the names or the forms of these other matrices which are represented there. This one is gonna be a 1 by 4 matrix because we only have one element in each column because there is 1, 2, 3, and 4 columns. So that is just one element per column. Now if you ran in this direction in the horizontal pathway, you would actually find 4 elements, so that makes for 1 by 4 matrix. So this is particularly a row matrix because it has just one row. So let us go back. Let us solve some questions using these matrices. So let's say that you were asked to find the value of 2a plus c. How are you going to solve it? So first thing we need to do, as you know from Bob Mass, we need to add a to c first of all, then multiply the answer by 2. So what is a? Now a, we know that is 2, 1, 4, we have 1, 0, 3. And so we need to add this to c. So this is the matrix C. So that is going to be 1. You have negative 1 there. And this is 0. This is going to be 0. So we have 4 and 5. So what you need to know for, what you need to know for the addition of matrices, you need to have all the elements in a row be the same for each matrix. Now basically what I mean by that, I'm trying to say that the number of elements which are in each row in column should be the same for each matrix. So if we have the first matrix having 3 elements in a column, then there actually also needs to be 3 elements in the second matrix, in the row of the second matrix. Sorry, in the column rather. So this is actually 2 elements in the row, and there should also be 2 elements in this row. So basically that is how it works. Now let's find the answer to that. Now this actually comes off easy. Every element in each position chooses its partner in the other matrix and gets added. So this basically should be 2 plus 1, which gives us 3. And this is going to be 1 plus 0, which gives us 1. And here we have 1 plus negative 1, which is basically going to be 1 minus 1. So that gives us 0 there. And here we have 4 plus 0. So that is going to give us 4. Now we have 0 plus 4, which gives us 4. And here we have 3 plus 5, which is going to give us 8. So this is the answer for A plus C. But we need to multiply A plus C by the scalar 2. So 2 standing here is actually a scalar. So we need to multiply this by 2. Now, I need to make this be this way. Well, I could actually do it this way or leave it. So let me write it rather this way. So we have 2 multiplying by each element which is present within this resultant matrix, which is going to give us 6, 2, 0, 8. You have 8, and here you're going to have 16. So that is the answer for 2a plus c. basically. That is the answer to that one. So let's try another one. How about if you are told to find the answer to 3f minus 2f to the power of t? Now, what does this really mean? 2f to the power of t. Now, if you have this basically means the transpose of the matrix F. So what is going to be a transpose? Now, this is the matrix F. So let us write that out. Now, this is the matrix F. So if we need to transpose it, you make up the first row to become the first column, second row becomes second column, and the third row, that is going to become a third column. So basically, transpose of a matrix is a kind of changing the row into the columns or changing the columns into the rows. So if you have this as a first row, this is actually the first column, this should now become the first row. So you actually change it. So let us do that. Now, F transpose, that is going to be 1, 0, 6, and we will have 2, 1, 2, and this is going to be 1 minus 1 and 1. So this is actually F transpose. Now we need to add it to F itself. But before we do that, we need to multiply 2 as a scalar to this matrix. So let's take everything gradually. So first off, we have F transpose, and that has been written. So we need to multiply 2 by F transpose. Now F transpose, this is it. We have 1, 0, 6, and this is going to be 2, 1, 2, and this is 1, negative 1, and 1. Okay? So let's see what that gives. This is going to be 2, 4, 2, and here we have 0, 2, negative 2. We have 12, 4, and 2. So basically, this is 2F transpose. Now we need to find 3F. So let us try to do that. 3F, that is going to be 3 multiplied by the matrix F. So that should be 1, 0, 6, 2, 1, 2. And this is 1, negative 1, and 1. So this is 3, 0, 18. You have 6. This is going to be 3. And this is 6. Then you have 3 multiplied by 1, which gives us 3. And then we have 3 multiplied by negative 1. That is going to give us negative 3. And then the last one, we have 3 there. So this is actually 3F. Now we need to take this and subtract it away from 3F. So let's see how that's going to be done. Okay, so we need to hold these ones at the back. Just going to wipe these out. So this is what you have. And I need to write this in front so that we're going to have a 3F. So this is going to be 3, 0, 18, 6, 3, 6. You have a 3, negative 3, well, and 3 there. So this is basically what you have. So we need to find out what is going to be the answer for this matrix. Now, just like I told you, if you do not have the same type or form of matrix in the two sides, you're actually not going to have the answer to that question. So basically, if this is a 3 by 3 matrix, then the other matrix also must be a 3 by 3 matrix for the operation to work. So we need to add 3 to 2, which gives us 5. And then we have 0 plus 4, which basically gives us 4. Then we have 18 plus 2. That is going to give us 20. And we have 6 plus 0, which is going to give us 6. And 3 plus 2, that gives us 5. And we have 6. Whoa, this is actually a very wrong thing I've been doing. Very sorry for that. I actually added. We were actually supposed to subtract stuff, not to add. So sorry for that. So let us go back. We need to take 3 and subtract 2 from it because of this symbol. So this is 3 minus 2, which gives us 1. And we have 0 minus 4, which would give us negative 4. And then we have 18 minus 2, which would give us 16. Whoa. I think I need to remove that. So we have 6 minus 0, which is going to give us 6. And 3 minus 2, that gives us 1. And then we have 6 minus 2. So that basically changes to 6 plus 2, which is going to give us 8. And here we have 3 minus 12. So that should give us negative 9. We have negative 3 minus 4. So minus 3 minus 4, that is going to give us minus 7. Now we have 3 minus 2, which is 1. So this is the answer to the question 3f minus 2f transpose. Try this one. Say you were given to find the value of b plus 2d transpose. Feel free to pause the video and try it out yourself. So let us start with d transpose. Now this is d, so we need to transpose it. So d transpose will basically change from, this is actually a 4 by 1 matrix. This is a 4 by 1 matrix. So we need to change it from a 4 by 1 to a 1 by 4. That will basically be the result of the transpose of a matrix. If you have a matrix form given, the transpose of that matrix will be the switching of the numbers within the form. So if you have 4 by 1 and we wanted to transpose such a matrix, the transpose will change to a 1 by 4. So just bear that at the back. Now this is going to be 6, 1, 2, and 3. Now that is what you have. Now we need to multiply 2 as a scalar by this vector. Bear in mind, matrix is actually a vector, so that comes off easy. So this is going to be 2d to the t. Now if we multiply this, this is going to give us 12. And this gives us 2. And this is going to give us 4. And here we have 6. So this is 2d transpose. And we need to add it to B. So this is the matrix B. Now as you can see, the matrix B is of the same form as we have 2d to the t, which actually works. So let us work that. This is going to be B, which is a 1, 0, 2, and 6. And we have plus this stuff here, which is 12, 2, 4, and 6. So this is 1 plus 12. And that is going to give us 13. And we have 0 plus 2. That is going to give us 2. And there is 2 plus 4, which gives us 6. And we have 6 plus 6, which gives us 12. So this is basically the answer to B plus 2D transpose. That is going to be the answer. Now also what you need to know is that if we have a form of a matrix, let us say 4 by 3 matrix added to a 4 by 3 matrix, the answer should basically still be the same form of a matrix. The answer should still be a 4 by 3 matrix. If that is not what you find, then the answer would actually be wrong. And so here we have a 1 by 4 matrix added to a 1 by 4 matrix. And that obviously is giving us 1 by 4 matrix. So we are on track and we're correct. Now try this one. What is going to be the answer to E transpose plus C minus 2A? So this is the matrix E. This is a 2 by 3 matrix. Now we need to transpose it. So obviously the transpose will become a 3 by 2 matrix. Then we need to add that to the C matrix and then subtract negative 2A from the answer. So what is E transpose? Now E transpose would be 1, 1, 0. And we're going to have 2, negative 1, and 7. Now as you can see, this is 3 by 2. Because we have 3 elements in the column and 2 elements in the row. So we need to add this to the C. So C, we got 1, negative 1, 0. We got 0, 4, and 5. So let's add these ones. That is going to give us 2. Now we have 1 plus negative 1. That is basically going to make a 0. Now this is 0 plus 0, which still gives us a 0. And you have 2 plus 0, which is going to give you 2. Then we have negative 1 plus 4. That is basically 4 minus 1, which gives us positive 3. And this is 7 plus 5, which gives us 12. So this is the answer for E transpose plus C. Now we need to subtract 2A from the answer E transpose plus C. So let us find what 2A is. So this is A, this is 2, 1, and we have 4. This is 1, 0, and this is going to be 3. So the matrix being formed will be 4, and we have 2. This is going to be 8. You have 2 here. This is 0, and this is going to be 6. So that is basically the 2A that we have. Now we need to subtract that from this matrix. So that is 4, 2. This is 8. You got 2, 0, and 6 right there. So what is going to be the answer to this question? Now this is going to be 2 minus 4, which gives us negative 2. Then you have 2 minus 2. That gives us 0. Then this is going to be 0 minus 2, which basically forms a minus 2 there. And this is 0 minus 8, which gives us minus 8 there. Then we have 3 minus 0, which is going to be a 3. Lastly, we have 12 minus 6, which gives us 6. So this is going to be the answer to the question. Now try this last one. Say you are given to find the value of negative 3 over 2 of the matrix G minus the matrix F. What is going to be the resultant matrix? So we know the matrix G. This is the matrix G. And we have the matrix F. This is the matrix F. So let us go gradually. We're going to start with the matrix G. So that is going to be negative 3 over 2 multiplied by the matrix G, which is negative 2, 0. You got 8. So this is going to be 6. This is negative 4. And we have a negative 2. This is 2, 6, and 0. Now, what we need to do, we need to take negative 3 over 2 and multiply by each element which is present within this matrix. Now, if I multiply negative 3 over 2 with 2, basically 2 is going to cancel the 2 below there. So that is going to make a 1. And so we basically should have a -1 multiplied by -3, which is going to give us +3. So that is the answer for the first entry. Now for the second entry in column 1, we have this whole stuff multiplied by 0, which basically should stay back as 0. Now this is going to be -3 multiplied by 8 in the last entry of the first column. So if you have -3 halves of 8, what is that going to give? So basically this is 2 into itself one time and 2 into 8, that is going to be 4. So we are talking about 4 multiplied by -3. Now 4 multiplied by -3, that is going to give us -12. Then we have -3 halves multiplied by 6. What should that give us? Now if you use your calculator, you basically should find -9 as the answer. Now we have -4 multiplied by -3 halves. So this makes it to be +6. And for this one, we're going to have +3. Now we have 2 multiplied by this. So this should give us -3. Now -3/2 multiplied by 6, that is going to give us -9, yeah, as we had in this case. So this should still be a -9. And then the last one, we have 0, basically forming 0 there. So this is going to be -3 halves of g. Now bear in mind, if you have ordinary numbers multiplying by matrices, which are basically vectors, this is basically what we call scalar multiplication of vectors. So this is -3 halves of the matrix G, and this is the answer. So we need to subtract the matrix F from this answer. Now what is the matrix F? So we have F to be 1, 2, 1. This is 0, 1, and -1, and then we have 6. We got 2 and 1 right there. So we need to operate on these ones in the final step. So what is that going to give us? Now, I'm just going to shift stuff to this side. So we're going to have 3, 0, and -12. We have -9. This is going to be a 6, and we have a 3 there. So -3, this is -9 and 0. And this stuff is subtracted from this answer. So that is going to be 1, 2, 1. This is 0, 1, -1, 6, 2, and 1. So let us work this one in the final step. Now we have 3 minus 1, which gives us 2 basically. Then this is going to be 0 minus 2. That should be -2. Then we have -12 minus 1. So that should give us -13. Then we have -9 minus 0. So that should give us a -9. And here we have 6 minus 1, which gives us a 5. And we have 3 minus 1. So you know that should give us 3 plus 1, which should be 4. And we have -3 minus 6. So that should give us -9. Then here we have -9 minus 2. That should be -11. And here we have 0 minus 1, which is going to be -1. So this is basically the answer to the question, -3 halves of the matrix G minus F. This is the answer. So that brings us to the end of this first part of the video. Check out my channel to find more videos on matrices. I also have another video about multiplication of matrices, and so we're going to look at that in just a little bit.